Welcome back to Science Mordernizers. Welcome back to this video. Today we are going to see the Aptitude Medical Entrance Examination, the 2018 session Physics. So we begin with the first question. It reads, two electric charges -6 microcoulomb and +6 microcoulomb are placed respectively in 2 points A and B, distant 1 meter apart. The electric field is known at point C. A, located in the middle of the segment AB. B, located outside segment AB at 1 meter from A. C, located outside segment AB at 1 meter from B. D, outside the line AB. E, no answer is right. So we are going to get a representation of the scenario. So this is negative cure, and here we have positive cure. So the distance between the two charges is 1 meter, and so this is point A and this is point B. Nowhere along the line AB with the field strength be null, because the electric, when we draw the electric field lines, we are going to see that they will definitely meet along AB. So the field strength can be null not within AB but relatively outside AB, and we can actually get the exact point. So if we define the point, let's say to be that's the point C, such that the distance from A to C is x, and so the distance from B to C will simply be x plus 1. So we can now calculate the field strength, the electric field strength which the charge A is going to have. The electric field strength felt by on C due to charge A, that's the charge negative cure. So we are going to have the electric field strength E is given by K cure divided by R squared, and so this will be K into -6 microcoulomb divided by R squared. So the distance from A to C is x squared, from where we have -6K divided by x squared. That's going to be equation 1. Now that of B, EB, will simply be K times the charge +6 divided by x plus 1, all of that squared, and so I get 6K divided by x plus 1, all of that squared. We call that equation 2. Now at the point where the field strength is null, the sum of these two fields should give us 0, and so if we take EA plus EB, we are looking for the point where it can be null. So this means I will have -6K divided by x squared plus 6K divided by x plus 1 all squared is equal to 0. And so this means I'll get 6K can cancel out. So 6K can cancel out, this and this can cancel out if I divide all two by 6K. So simplifying, I will have 1 on x squared is equal to 1 divided by x plus 1, all of that squared, and this means we have x squared will be equal to x plus 1, all of that squared. So this also implies that I have x squared is equal to, expanding the right hand side, I have x squared plus 2x plus 1. So the two terms in x squared will disappear, so this term will simplify with this other term, and so we will be left with 2x plus 1. 2x plus 1 will be equal to 0, from where x is equal to -1/2. Now the negative, we have x is equal to -1/2. So what's the reason of the negative sign? So the minus sign simply indicates that the point is on the left of the positive charge. So we have the charge positive Q, and so the negative indicates that it is actually on the left of the positive charge. So that is the respective distance. And so definitely we see that amongst the option which best describes it is option D, because it is half at the left of the positive charge. So definitely it cannot be null along the line AB. So if the distance, this little distance, is x, and x is a half in magnitude, so we see that it's going to be null at a certain point C, which is going to be 1 plus x. So the negative convention simply tells us that the point x is not found on this side, but rather on this other side. So the correct option is option D. Okay, so we are going to proceed with question number 77. A generator of electromotive force supplies a circuit in series, a motor 18 volts and 7.5 ohms, and an incandescent lamp 3 ohm. The intensity of the current in the circuit is 0.5 amperes. The value of the internal resistance of the generator is... Okay, so we are simply going to apply Kirchhoff's voltage law, that the EMF E will simply be the sum total of the voltage drop across, we have the lamp, plus the voltage drop across, we have the incandescent lamp, and we have the motor. So across the motor, that's VM. So all of them are connected in series, and also this total EMF, or the effective EMF, is also given times the total current flowing in the circuit times the equivalent resistance. Now we have that the voltage drop across the total current in the circuit, is equal to 0.5 amperes, and we can get the equivalent resistance. So the equivalent resistance will simply be 7.5 ohms plus 3 ohms plus the internal resistance, since the internal resistance of the generator is going to be in series with that of the motor and the lamp. So it means our EMF E will simply be, and our EMF is given by 24. 24 will simply be equal to 0.5 times the equivalent resistance. The equivalent resistance will be 7.5 plus 3 plus the internal resistance of the generator. And so this gives 48 is equal to 7.5 plus 3, which is 10.5 plus the internal resistance. And so we get the internal resistance R to be equal to 48 minus 10.5. So 48 minus 10.5 is 37.5 ohms. So the correct option is option B. Question number 78. An electric motor operating with a voltage of 120 volts provides a mechanical power of 240 watts. This motor, which is crossed by a current of 2.5 amperes, has an EMF. So we can calculate the potential, so the power input. So the power input P in is simply equal to VI, and which is going to be 120 times 2.5 amperes. So this numerical value gives 300 watts. It's 300 watts. P out, it's simply equal to 240 watts, and so we can calculate the power loss. So P loss will simply be P in minus P out, which is 300 minus 240, which will give us 60 watts. And so with the P loss, we can get the resistance of the motor, of the electric motor. So P loss is given by I squared R, which is equal to 60. And so the resistance will simply be 60 divided by I squared, so that will be 2.5 all of that squared. So 60 divided by 2.5 squared gives 9.6 ohms. And so the EMF E will simply be V minus IR. This means we get the initial voltage, there was 120 volts. So 120 volts, that's P in or V in, that will be minus IR, that's 2.5 times 9.6. So 120 minus 2.5 times 9.6 will give us 96 volts. So this will be equal to 96 volts. So it means the correct option is option C. Question number 79. In a parallel plate capacitor, an electric field vector A has a direction perpendicular to the plate B, has a direction parallel to the plate C, has the sense of increasing potential D, is directed parallel to the plate E, none of the above. So if you have the plates of a capacitor, this is a positive terminal, that's a negative terminal, so the direction of the field line is always perpendicular to the plate. So correct option A. Question number 80. Calculate the impedance of a coil of resistance 10 ohm and inductance 59 milliamperes applied to a sinusoidal voltage of frequency 50 Hz. So the impedance Z, we have a resistive and an inductive circuit, so it's going to be the square root of R squared plus the inductive reactance, all of that squared. But the inductive reactance XL is omega L, which is 2 pi f L. So the frequency is 50 Hz, and so we get XL to be equal to 2 pi times 50 times 59 milliamperes. That's 59 times 10 to the negative 3. So we can get the value of the inductive reactance. So the 69 times 10 okay, so it's approximately 18.53535354. Okay, so with this I will just get the value of the impedance. So the impedance will be the square root of 10 squared plus 18.5354 squared. So all of that in the square root. So numerical application will yield 21.06 ohms. So there is no answer. None of the above is correct. Okay, question number 81. The induced EMF of a coil of negligible resistance has a value of 4.5 microvolts. What is the value of the voltage at the ends of the coil? It was to be 4.5 microvolts. Correct option D. Number 82. 314 meters of an isolated copper wire of radius 1 millimeter is wound in turns around a cylindrical nucleus of diameter 10 centimeters. The number of turns of the solenoid is, so I have the length of so the length of the copper wire is 314 meters, and so I get that in order for me to make a turn on a cylindrical nucleus which has a diameter of 10 centimeters, so it means my one complete turn is going to be equivalent to the diameter. So one turn will be equal to the circumference of the equivalent circle, which is going to be pi diameter. And so we can get now how many turns can we exhaust the 314 meters. So we simply get that the number of turns, let's call it n, the number of turns n will simply be 314 divided by pi diameter. So this is going to be 314 divided by pi, which is pi times diameter. The diameter is 10 centimeters, and 10 centimeters is 0.1 meter, and 314 divided by pi. 314 divided by pi divided by 0.1, we have 99.49. So this would be 99.49, 999, so 0.49. So this will be approximately equal to 1000 tons. So we have C. Now the next, a domestic iron, bracket 220 volts, those are the ratings. So that's the rating, sorry. So the domestic iron 220 volts, 1000 watts, functioning without interruption from 4 p.m. to 6:30 p.m. consumes electrical energy of A, B, C, D, E. So electrical energy E is simply equal to PT, and we see that the time of functioning T was in the interval 4:30 p.m. 4:30 p.m. 4 p.m. rather 4 p.m. right up to 6:30 p.m. and so this is an equivalent in hours of 2 hours 30 minutes. And so in other words, since 1 hour is equivalent to 60 minutes, so 2 hours is 120 minutes. So this is an equivalent of 150 minutes. And so the E will simply be equal to PT, and the rated power is 1000 watts. So we are going to get 1000 times 150 minutes, that will be times 60 in seconds. So this will be equivalent to 15 times 6 is 19. So this will be 150 times 60 is going to be 9000. So I'm going to have 9000 times 1000, which is going to be 9 times 10 raised to the power 6 joules. And so the correct option is option B. Question number 84. If the atomic nucleus 23490 thorium emits a beta particle, the resultant nucleus will contain, so I have 23490 thorium, and this emits beta particle. So I'm going to have 0, -1 beta plus the certain element X. So this will be 23490. From the conservation of mass, this should be 91. And so the number of neutrons of the resulting nuclei is N is equal to 234 minus 91, which is going to be 143. And the number of protons is let's see, the number of protons is 91. So the correct option is option E. The corpuscular character of light is highlighted by diffraction, luminous interference, refraction, dispersion, and photoelectric effect. Correct option is E, since it explains the fact that when electrons have been ejected from the surface of a metal, it means that they actually came in contact with a pack of energy since they were initially at rest. So in order for them to gain some energy to displace themselves from equilibrium position, it means that the entrant radiation contains some pack of energies, which is actually called photons. Those are packs of energy. So photoelectric effect highlights the corpuscular character of light. For a given photoemissive cell, which of the following option is correct? A. The outgoing electric current depends on the wavelength. B. The threshold frequency does not depend on the cathode metal but on the anode metal. C. The threshold frequency depends on the number of photons reaching the cathode per second. D. The intensity of the outgoing current is greater when it's lighted by visible light than ultraviolet. E. None of the above. So analyzing the options, the option A is correct, Option B says the threshold frequency does not depend on the cathode. No, it depends. C says the threshold frequency depends on the number of photons reaching on the cathode per second. The threshold frequency is already the property of a metal, so it's not correct. Next, the intensity of the outgoing current is greater when lighted with visible light than ultraviolet. So we can use the mnemonic: real men in Vegas use expensive gears. So this is the electromagnetic spectrum in order of increasing frequency. And so we see that the visible light and the ultraviolet light appear next to each other, and UV has a greater frequency compared to the visible. And so if we use them in order to eject electrons from the surface of a metal, ultraviolet will definitely do the best job. So this option is not correct. All of the above is neither correct. So the best is option A, because for photoelectricity to occur, electrons must first be ejected, and it is the ejection of those electrons which are definitely going to create a current intensity. So correct option is A. Question number 87. What mode of disintegration is carbon? Is a carbon-14 nucleus, so it's simply the beta emission. Question number 88. What are the values in nanometer of the wavelengths limiting the visible part of the electromagnetic spectrum? It is between 380 and 750 nanometers. Question number 89. Radioactivity of an element is influenced by A, the chemical structure; B, the binding energy per neutron; C, the electronegativity; D, the Avogadro's number; E, none of the above. So none of the above is correct. The correct option is option E. So it is simply because the radioactivity of an element is not directly influenced by the chemical nature, and the radioactivity also is primarily determined by the stability of the atom. So definitely the binding energy per neutron, electronegativity, Avogadro's number, and the chemical structure, they are not directly related to how radioactivity can be influenced. So the correct option is option E. Which is not an SI unit? A, the meters; B, kilogram; C, gallon; D, pascal; D, E, joule. So the gallon is not an SI unit. So meter is the SI unit of distance or length, kilogram for mass, pascal pressure, stress, and E, joules for energy. The origin of Laplace force is electromagnetic. So correct option C. Okay, question number 92. In vacuum and in the same region, A, heavy bodies fall less quickly than light bodies; B, light bodies fall less quickly than heavy bodies; C, light bodies fall faster than heavy bodies; D, heavy bodies fall faster than light bodies; E, all bodies fall in the same manner. Correct option is E. Number 93. An elevator has a total mass of 1.8 tons. At the start of the ascending phase, the resistance to the displacement is equivalent to 12% of its weight, and its acceleration has a value of 0.2 g, where g is the acceleration due to gravity, and we take it to be 9.78. The magnitude of the tractive force exerted by the cables is. So let's assume this is an elevator. So the elevator has a weight W. On the ascending phase, it has a tractive force, let's call the force F, and a resistive force which is 12% of the weight, 12% of W. And so the acceleration is 0.2 g. So from Newton's second law, resolving the forces, as the resultant of the forces is equal to ma. So I have F minus 12% of W plus W is equal to the mass times the acceleration. So 12% is 0.12, and 0.12 W plus W will simply give us 0.12 plus this is minus W. So I have F minus 1.12 W is equal to MA. And so my force F will simply be MA plus 1.12 W. So the mass is 1.8 tons. So the total mass of the elevator is 1.8 tons. So I get 1.8 tons in kilograms times 10 to the power 3 times the acceleration. The acceleration is 0.2 g, so that will be 0.2 times 9.78, and this will be plus 1.12 times the weight. The weight is mg, which is 1.8 times 10 to the power 3 times the acceleration due to gravity, 9.78. So numerical application will be, numerical application gives 7.28 Newton. So we check the options. 2, 3, 2, 3. So we have 23.24. So we can write it as 1, 2, 3, 4. So 2.324. 2.324. So this was not well reported. 2.324 times 10 to the 4, yes, it's okay, so it was well reported. So the correct option is A. Number 94. Two steel balls B1 and B2 are allowed to fall from the same horizontal plane. Through a height of 25 meters to the ground. At the initial moment, B1 is released without speed, whereas B2 is launched with a horizontal speed. At time t equal to 1 second, the height of B1 is higher than B2, the height of B2 is higher than B1. The heights of the two balls are equal. The magnitude of the speed depends on the magnitude of the speed of the two balls are equal. E, none of the above. So let's analyze the problem keenly. So what we have is, we have two balls B1 and B2. Let's say this is the height to which both balls are supposed to fall. This is the height to which both balls are supposed to fall. So I can call it H. And so the first ball falls without initial velocity and it goes vertically downwards, and the second ball B2 is projected with an initial velocity, that's u of x. It means that it does not have a vertical velocity. So at the end, both balls are going to fall the same distance. So the correct option here is option C. Now let us see it in terms of equations. So we are comparing the vertical displacement. So the vertical displacement s of y is equal to u of yt plus a half gt squared. So for ball 1, we are going to call it s1. It does not have an initial vertical speed, so it means the equation of motion will be equal to a half gt squared. For ball 2, all we have is the initial horizontal velocity, so it means the ball is going to perform such a trajectory. So definitely it tells us that since if you want to write the vector form of the initial velocity, the vector form of the initial velocity will be u of x is given, so we can call it to be u, but the vertical component is 0. So it means the vertical displacement of ball 2 will also be given in the form a half gt squared. So you see that at any instant t, the vertical component of the displacement, or the vertical displacement of the two balls, are always going to be equal. Plug in 1.5 and 1.5, you get the same value. So the correct option is C. Question number 95. The work done by a force perpendicular to the displacement is A, negative, B, positive, C, null, D, maximum, E, none of the above. So the work done by force W is simply given by the force times the distance moved in the direction of the force times the cosine of theta. So this is if you are inclined at a given angle theta. So we see that if the force and the displacement are orthogonal to each other, we are going to have a case where a force can be applied like this, and we observe a displacement in this direction. So what we get is the angle theta becomes 90 degrees, and when theta is 90 degrees, we get Fd times the cosine of 90, and the cosine of 90 is 0. So correct option is C. Question number 96 to 99. A ball thrown from a point O on a horizontal ground with a speed v0 inclined at an angle alpha with respect to the horizontal, neglecting the air resistance and considering the ball to be a point mass. So let's get the possible motion path. So we get this. So it's a projectile of this nature, and so we have the component of the speed. The angle of inclination is alpha. The initial speed has two components. Here we have u times the cosine of alpha, and here we have u times the sine of alpha. So the maximum point attained is this point, and the distance from here right up to here is what we call the maximum height. So for a projectile, you also have to notice that the horizontal component of the speed is constant throughout the motion. Now, question number 96 says, during the motion of the ball, the acceleration vector is A, remains parallel to the direction of flight and in the same direction. B, remains parallel to the direction to the flight trajectory but in opposite direction. C, remains perpendicular to the flight trajectory. D, changes direction at the apex of the trajectory. E, none of the above. None of the above. So the correct option is it changes apex. It changes direction at the apex of the trajectory. That's at this point. As the ball is moving, it is moving with an acceleration which is contrary to that of the acceleration due to gravity, since the direction of G is downwards. And when it changes apex, we see that it follows the orientation of the acceleration due to gravity. So the correct option is option D. Okay, next. At the summit of the trajectory, the speed is A, null, B, vertical, C, minimal, D, maximal, E, none of the above. The correct option is option C, it is minimal. So at the vertical, at the maximum point, this at the summit of the trajectory, only the vertical component of the velocity is 0, but we still have the horizontal component u cos alpha, which is acting, reason why the ball keeps on moving following this path. But if at the maximum height the velocity or the speed was totally null, then the ball could fall vertically downwards. So, and also the speed is minimal, since the speed is the magnitude of the velocity, which is the square root of vy squared plus vx squared. But since vy is already equal to 0, so it means the speed will simply be equal to vx, which is minimal. And question number 98 says the height of the trajectory at the summit is A, independent of V naught, B, independent of alpha, C, proportional to V naught, D, inversely proportional to V naught, E, proportional to the square of V naught. So the height at the summit is given by V naught squared sine squared alpha, all of this divided by 2G. So we clearly see from here that the correct option is option E, proportional to the square of V naught, since it depends on alpha. Question number 99. A car moves at a speed of 90 km per hour. To which height should it fall without initial velocity to attain the same speed? So the height which you can attain is given by u squared divided by 2g, and so we are looking the height which you can attain with that speed, so it means h will be equal to 90 kilometers per hour. So let's get the expression of the speed in meters per second. So u is 90 kilometers per hour, which is 90 kilometers times 1000 per hour divided by 3600. So this simplifies this, and this simplifies, and so we are left with 900 divided by 36. So 936 is simply 25 meters per second. So from here we can now calculate the height to which the height which it's going to attain. So the height is simply given by u squared on 2g, which is 25 squared divided by 2 times 9.8. So So we get a height, an approximate height of 31.88 meters. Okay, so let's try. I used 9.8. Let's see with 10. So 625 divided by 20, it gives 31.25. So if G is 10, the H gives 31.25 meters. So the correct option is option C. Okay, so let's get to the last question. So we see that the electrical energy we receive by a receiver whose terminal voltage is 3 volts when it is traversed by a current of intensity 1.0 amperes during 20 milliseconds is, so E is equal to VIT. So the voltage is 3 volts times 1 ampere times 20 milliseconds, that's times 10 to the negative 3. And this gives 60 times 10 to the negative 2, which is the same as 6 times 10 to 60 times 10 to the negative 3, which is 6 times 10 to the negative 2. So the correct option is option C. So this brings us to the end of this video. Thank you very much for watching. Please do not forget to like, share and subscribe, and we wish you best wishes for your examinations ahead. Stay blessed and see you in the next video.